When you decided to take physics, you maybe had no idea that the unit circle, sine, cosine, tangent, trig stuff was going to make a reappearance. But have no fear, it is incredibly common. We're going to break it down step by step so that you don't have to worry about it, so that you're going to be all good in the future. And if you ever forget how to do trig stuff, you will remember exactly how to rederive it, which is how I love to do it. So on your own version of a whiteboard, you can follow along with me. If you want to be extra special, you can use the fancy line tools on Zoom here to make your axes to start out. So what we're doing here to start out is simply drawing our XY plane, and we're going to generate a unit circle. So if you were in a trig class, your teacher might give you a graph that looks something like this to fill out with all the different angles and stuff, but we're going to keep it super basic, super simple, and talk about it in a way that it will just come back to you. So the reason we start with the unit circle is because it has this magic property of a radius of 1, and it's centered at 0, 0, aka the origin. So if it has a radius of 1, that means all of the hypotenuses are going to be a length of 1 of each of these triangles that we are going to be drawing, right? We're talking about trig stuff. So trig equals triangle, specifically right triangles. Okay, so with all of the triangles that we're going to draw, the reason that we use the unit circle to illustrate this because it has the hypotenuse of 1. So we're going to have some angle theta, and the basic trig functions as they're defined, sine of theta is our opposite over hypotenuse. Our cosine of theta is our adjacent over hypotenuse. Now we're going to write this in terms of x, y, and 1. So remember, our hypotenuse is 1. So the opposite side compared to this theta is going to be this vertical thing, which is our y. Our hypotenuse is 1. Cool. So sine of theta is simply equal to y for the unit circle. And the nice thing is that this concept can generalize, but we'll talk about that in a little bit. So now we've established that this is our y, and for our adjacent over hypotenuse, again, the adjacent side to theta, that is not the hypotenuse, is going to be our x value over our hypotenuse of 1. Therefore, cosine theta for the unit circle is equal to x. Great. Now, tangent of theta is a derivative, not a calculus derivative, but is derived from sine and cosine. So tangent of theta, when we learn SOHCAHTOA, it's that it's opposite over adjacent, but it's also equal to sine of theta over cosine of theta. And that further breaks down into opposite over hypotenuse over adjacent over hypotenuse. So the fact that we have divided by the hypotenuse in both the numerator and the denominator means that they cancel. And so that is how we get ultimately to opposite over adjacent. So in truth, tangent really is the ratio of sine over cosine, which again also means that if we have defined within the unit circle that sine of theta equals y, cosine theta equals x, opposite over adjacent or sine over cosine is equal to y over x. So now when we're talking about physics, specifically vectors, we want to figure out the magnitude and the direction. Now, let's say that we have the x and the y components. Now, again, based on trigonometry, Pythagorean theorem tells us that if we have a, b, and c, a squared plus b squared equals c squared. And in turn, if we substitute that in for what we have here, x squared plus y squared equals 1 squared, which is 1. Great. So now this is where we're going to get into the idea of a generalized way of calculating the magnitude. So this, again, this specifically is for the unit circle, the fact that our magnitude here is 1. And that goes back to what we said at the beginning. The reason that the unit circle is so useful is because we have a constant magnitude of a unit vector in all directions. So now let's, instead of a unit vector magnitude of 1, if we instead call this vector v, just for fun, then we can say say the magnitude of v squared is equal to x squared plus y squared, which then means that the magnitude of v, sometimes you'll see it with a double line, sometimes just with a single line on either side, is equal to the square root of x squared plus y squared. We started to now thread in this idea of we can have any vector generalized to this, but let's see why that is. So again, this is for any triangle with sides a, b, and c, a squared plus b squared equals c squared. So if we're defining a equal to x and b equal to y, that means if this is, again, some magnitude of the vector v, that's where we get this general equation. But indeed, for the unit circle, that c is always equal to 1, regardless of the direction. Oh, funny I should mention direction. We're going to get into that right now. So now when we're talking about the direction, we want ultimately theta here. How do we get a formula or an equation that represents theta? If you have the magnitude of the vector already, you can use either sine or cosine, because we can now rewrite our sine and cosine. So sine of theta is equal to opposite over hypotenuse, where the opposite is still our y, but now in the general case, the hypotenuse is going to be whatever the magnitude of the vector v is. This is our overall vector. Y here is the y component of vector v. If you have this, then what that means is that y is equal to the magnitude of the vector times sine theta. And similarly, x is equal to v cosine theta. So that's a little bit of a side note that connects what we were talking about before to the more general case. But if we're trying to find the magnitude in the direction, oftentimes you won't have the magnitude to begin with. So if you first do the magnitude of vector v equals x squared plus y squared, square root of x squared plus y squared, yeah, you'll get the magnitude. And then you can use that if you want, or if say you wanted to calculate the direction first before the magnitude, how would you do that? Well, then you have theta equals, this is where we're going to use the tangent. The fact that tangent of theta is equal to, remember, regardless of what the hypotenuse is, this is why this is so key. So if you haven't found the magnitude yet, you don't know what the magnitude of the vector, you don't know what the hypotenuse is. And so that is going to be no matter what equal to y over x. And so therefore theta is going to be the inverse tangent of y over x. And this is what we see frequently. So theta equals the inverse tangent of y over x. So that is your basic review of trig stuff, starting with the unit circle and then connecting it to a general vector with magnitude v. And I'll show you this also, the fact that we have sometimes the direction is indicated by this of, you have vector v over the magnitude that gives purely the direction. Kind of normalizing it, we call, to a unit vector length, and therefore just leaving behind the direction. So that's our initial review. I hope that was easy to follow, and you were able to sit with that and let the realizations hit at all the perfect moments. And until next time, peace out.